Okay, dear student, let's see what is there in this question. A moon M orbits a planet P. The gravitational field strength at the surface of P due to P is Gp, and the gravitational field strength at the surface of M due to M is Gm. Like if you take the example of the Earth and the Moon, so Gp will be the gravitation like 9.8 meter per second square, and Gm is the gravity at the moon surface because of the moon. Fine. So the ratio of mass, radius of the moon and the radius of planet is given, and the ratio of the mass is also given. Determine gm divided by gp. Okay. So first of all, we know this thing that the expression for the acceleration due to gravity is given by gm by r square. Now whether you call it acceleration due to gravity or you call it gravitational field strength, one is the same thing. Okay. And for both of them, the value is 9.8 at the surface of the earth, exactly same. So G is equal to Gm by R square. Clearly, the gravity is found to be directly proportional to M by R square. Accordingly, we can create our formula. So that will be the mass of moon divided by the radius of moon square. And here it will be the mass of earth or mass of planet and the radius of planet square. So this ratio, the mass of moon and the planet, is given as 0.055. So I'm just substituting it, and this value will become the reciprocal of it. So it will be zero point 0.1 by 0.27 square. This is going to be the correct answer, and with the help of calculator we can see, yes, I'm getting 0.75. Like I'm getting 0.74, but because IB is usually interested in two significant figures, here also they are giving two significant figures, here also they are giving two significant figures. So our answer should be reported in two significant figures. So this is how we do it, and the answer will be 0.75 for the part A. I will show you the mark scheme later. Let us move to the next question now. Point O lies on the line joining the center of M to the center of P. Okay. The graph shows the variation of gravitational potential V with the distance x from the surface of P to O. The gradient of the graph is 0 at O. State and explain the magnitude of the resultant gravitational field strength at O. So one thing is very clear, like IB is asking too many questions from this concept. So this becomes a very important, like imperative for us to understand what is happening here. You see, whenever we are talking about some field, gravitational field or the electrostatic field or something, there are two ways in which we can understand the field. Number one is with the help of the forces. Like at this point, you can clearly find the overall the gravitational force which has been created because of the earth and the moon. What will be the total force there? Point number two is you can find the total potential at that point. Potential because of the earth as well as the potential because of the moon. And we are going to add them. Now, force being a vector quantity, or like gravitational field strength will be a vector quantity. Obviously, we would be using vector signs there, but because it is linear, we are either like going to add them or we are going to subtract them. And the potential is a scalar quantity. Scalar means like we are not concerned with the directions, but both of the potentials will be just added similar to the simple algebraic addition that we do. These are the initial things that you must know. Now, another point, so this was the point number one that you need to know about this. Point number two that I want to tell you here is that for the attractive forces, potential is always negative. For the attractive forces, potential energy is always negative, potential is always negative. So obviously, if we are talking about the point P, let us say there is a mass here or there is a satellite here, obviously it is getting attracted by earth, isn't it? So attraction is there. It means that the gravitational potential energy will be taken to be negative, and at infinity the gravitational potential will be zero, and there will be no such case in which the gravitational potential can be taken as positive because it is not repelling. But whenever we are concerned with the repulsive forces, in gravitation we do not have repulsion, but in electrostatic we have. So in electrostatic, two positive charges are repelling each other. So what will be the potential energy? Positive. So what will be the potential? Positive. So in repulsive forces, the potential energy or the potential is usually taken to be positive. So this is the second point that I would like to make here, and you have to understand and you have to remember it, that for the attractive forces, potential is always negative. And in the case of gravitation, there is never, you never find repulsion forces. So clearly all the graphs of the potential will be negative wherever you go. You are near the moon or you are near the earth. Clear? It is never going to be positive, never going towards the zero even. It will be zero only at the infinity distance. Point number three that we have to remember in these kind of cases for both electrostatic field and the gravitational field is that the electric field strength, or you can say the gravitational field strength, they are always equal to the negative gradient of the potential. I am not calling it rate. There is a difference. Rate means that you have to differentiate with respect to time. Gradient means you are differentiating something with respect to position. That is called gradient. So this is negative gradient of potential. So, whether you are trying to find the electric field strength at some point or you are trying to find the gravitational field strength at some point, that will be given by the negative gradient of the potential if the graph is given for V versus X. Clearly, the V versus X graph is in front of you, and you can clearly find the slope here, and the negative of that slope will give you the gravitational field strength at that point. Clear? Okay. So we would be utilizing this formula in this question. Now, what were they saying now? What is the question? The gradient is zero. I would be coming to that point also. State and explain the magnitude of resultant gravitational field strength. Yes. Now let me explain you that. Now, having said these three things, the fourth point that you have to remember is that here at the surface of the earth, the gravitational potential will be having a finite value but kind of maximum. So it is negative, so it will be maximum magnitude. Okay. And in the case of moon also, like if you go for this, so at the moon surface only you will find the maximum value. It will go somewhat like this. So this will is going to be the maximum. I'm talking about the magnitude. Do not consider negative point and get confused about what is maximum. Maximum, when I say, it means the only negative magnitude values that I'm considering here. Point number four that we have to understand is that this point, this point is some point, like it is known as something. The name of that point is Lagrange point something. Okay. So Lagrange point is the point in the space where the total gravitational force will be zero. How come? The gravitational attraction of the moon, it is now equal to the gravitational attraction of the earth. Both of them are equal and opposite to each other at this very point. That is why this is like given a special name, Lagrange point, and it's a very specific point. Like in the case of sun and the earth also, there is one point which is Lagrange point, L1. And the the these agencies which are dealing, like NASA, or for from Indian point of view it is ISRO. So ISRO recently launched a satellite which was going to this point in the Lagrange point in the case of sun and the earth. So that point is nearest to the sun, and the satellite will go at that point, and it is always going to maintain its position at this point. So if this moon is going to rotate and it is going to come here, the Lagrange point is also going to shift its position to this place. So the satellite will also be moving like this, and the moon will also be moving like this. So that is the funny part of this point. Okay, it's a kind of fun fact, not required in this question. Anyways, let us now concentrate on the question only. So this is the Lagrange point. So the point number four that I want to tell you here that you must note is Lagrange point, which means that Potential is having minimum value in magnitude. Minimum value in magnitude. So the slope is zero here. Slope is zero. Slope means the gradient. It means that G, or in the case of electrostatic forces, this will be equal to zero. Okay. So this is the complete physics behind these points and everything. So I've tried to give my best in this much of the topic, like in minimum possible time. This is like best possible things that I can tell you here. Let us now move to the question. State and explain the magnitude of resultant gravitational field strength at O. So we can clearly say that the gravitational field strength at this point will be equal to zero. And when it comes to the explanation, we can clearly say that E or G will be equal to negative of dV divided by dx. If you want to write x, you can. If you want to write r, that will be even more suitable, because in the case of gravity we do it like that. So it will be negative dv by dr, and we can clearly say that the slope is given as zero itself. In the question it is given, and that is why the gravitational field strength at O will be equal to zero. There it is. The explanation is also given. Game over. Let us now move to the next question. Outline why the graph between P and O is negative. So why this graph is negative? So P is this point which is at the surface of the planet, and O is the Lagrange point in this case. So why this graph is always negative? Why it is not positive? So the only thing here that you have to say is that the gravitational forces are always attractive, and for the attractive forces the gravitational potential energy is always negative, and that is why the potential graph will always be negative. In the case of gravity, potential energy, the maximum value of potential energy is zero, and that even at infinity distance. It means that gravitational potential energy, technically speaking, can never be positive. Its maximum value is zero at infinity, and otherwise, within the field, it becomes more and more negative. Clearly, it is becoming more and more negative here. That will be the explanation. So, these two questions are done. We will go to the third point, but after going to the mark scheme, let us move to the mark scheme and see what is the answer that they are saying. Okay, the question number 6 here. So 6a, you can clearly see that the answer is 0.75. This is exactly what we got. B1 is that G is equal to negative Vg by Vr, which is the gradient of the graph. We are not using the word rate, we are using the word gradient. So in this question, you have also learned this fact, that when we can use gradient and when we have to use the word rate. As the force of attraction between P and M are equal, so you can say that the gravity there is zero, it is Lagrange point, like that. So this point, the gravitational field is attractive, so that energy is required to move away. Gravitational potential is defined as zero at infinity. Potential must be negative otherwise. Clear? So in the first explanation, they are saying that if you want to launch a rocket, that the rocket should move away from the gravitational field, obviously some energy has to be given to it. That is why it is chosen to be negative. So when we give some energy, the total energy becomes zero and it goes to the infinite distance. So in this question, in this explanation, he basically wants to refer to the derivation of escape speed. Okay, like that. So whatever you can write, like we have already seen, I've given you the explanation properly. Let us now move to the next question. Okay, show that the gravitational potential Vp at the surface of the planet due to the mass of planet P is given by Vp minus Gp into Rp, where Rp is the radius of the planet. Okay, so that we can easily show. We need not to go into calculus, by the way. We will see the mark scheme if they are going into the calculus or not. But according to me, if we want to bypass the calculus calculations, we will say that the formula for G is Gm by R square, and the formula for potential is negative Gm by R. So this Gm by Rp, like we can clearly substitute the values and we get the answer. So you can divide or you can substitute the value and you get the answer. So very easily we can prove it. Is it okay? This can be written as gm by r into 1 by r. Gm by r can be written as minus v. Clearly, v is equal to minus gr. Let us see the mark scheme if they are doing the same thing or not. If they're doing something else, I will explain you, but I believe this is what you should write. Let's see. Exactly the same thing. Clearly they are not going into calculus, they are not using the differential like we earlier they have given you the formula which was using the gradient, so we could have gone for the derivation also, differentiation also, sorry, but we do not want to go for the calculus. So vp is given by minus gm by r as the formula directly taken up from the topic 10. Gp is equal to gm by r square. Clearly vp is equal to negative gp rp. That's it. Now let us move to the next question. The gravitational potential due to the mass m at the surface of the planet P can be assumed to be negligible. So there is no effect of moon there. This is what we will assume. But it is not actually like that. But we will assume it because it is given in the question. Estimate using the graph the gravitational potential at the surface of moon due to the mass of moon. Okay, so estimating it with the help of graph gravitational potential. So gravitational potential, see the formula here, vp is equal to negative gp into rp. This is what we just derived. Yes, so we can write the same thing for the moon. So vp is equal to minus gm into the radius of the moon. Gravitational potential due to mass m at the surface of P is negligible. Estimate the gravitational potential at the surface of the moon due to the mass of the moon. So this is what we want to find. So negative gm and rm ratios are given, I think. So vp is given. Yeah, we can create ratios here. So vm divided by vp is equal to negative gm into rm, gp into rp. Negative and negative gets cancelled out. Vp value at the surface of the planet, we will take that value from the graph. And gm and gp ratio, we have found it to be 0.75 in the part 1. Rm and rp is already given, so we take those values from the question, we substitute here, and we multiply this. So I'm not going to do it. Let us go to the mark scheme and see if we are getting the same thing. Yes, they are also doing the same thing. Vm divided by Vp is Gm by this. This is 0.75 as we found in the part A. This value 0.27 is given in the question. Substitute the value and you're getting 0.2. Vp is taken from the graph, that is this. We multiply it and the answer is negative 1.3 10 to the power 7, 10 to the power 7 joule per kg. Be concerned with the unit also. That is very, very important. Okay, always write the units, and we are never going to work without units. Okay, so is there any other question? Yes, let us see what is there in next question. Draw on the axis the variation of gravitational potential between O and M now, because we have already now know the value of V that was coming out to be negative 1.3, I think. Okay, I must be wrong. Let us see what is the value that they have found. 1.3 into 10 raised to power 7. This is 6.4 into 10 to the power 7. Okay. Yeah, 1.3 10 raised to power positive 7. So it can be taken as 13 into 10 raised to power 6. So this will be mega. So basically it is 13 here. So this is 10 and this is 20, 12 or 13. That will be midpoint of this only. So it will be like this. So this will be the graph, and this is how we do it. This is like negative 1.3 10 raised to power 7. I hope I am 100% clear to you. This is how we do it. And this point, the slope is 0. For others, the slope is again becoming positive. So here the slope is positive everywhere. So this should be the answer. Let us go to the mark scheme and see if they are getting the same thing. Absolutely correct. This is what we are going to do. The shape end between 0.8 to negative 20. But anyways, because we already know that it will be coming out to be negative 13, why will we be doing this? Only if you are not able to solve that and you can take the approximate values there, then you can draw this kind of thing. Otherwise, it will be negative 13. That's it. Okay, dear students, so thanks for watching the video. This is Professor Varun. Thanks for joining. Please share the video with all your friends. Tell them to join the YouTube channel. All the best. Bye. See you in the next video now.